Good morning, everybody. This is a live extreme weather briefing. We have a lot to talk about. There's a complex of storms that moved through central Oklahoma early this morning. I heard a lot of thunder this morning from the Norman area. Now that complex of storms is continuing through eastern Oklahoma, Tulsa, down toward the I-40 corridor, down through Muskogee, Bix, just west of Muskogee, getting that heavy precipitation to the northwest of Henrietta, home of Troy Aikman, I believe, out here along the I-40 corridor near Okemah as well. Just some heavy rain so far, but there is a threat of strong tornadoes today. Southeastern Texas Panhandle through central southern Oklahoma. That does include the Oklahoma City corridor as well. And I think that there could be a couple of different target areas today. One could be a little bit further east along the warm frontal zone. You could easily argue targeting the I-44 corridor, for example. Lawton up through Oklahoma City. I can certainly see out off to the east along the warm frontal zone some supercell storms developing across that environment. Low-level jet then will also accelerate over top the warm frontal zone. I do see supercell storms developing as early as about 3 p.m. across the southeastern Texas Panhandle, right where that warm frontal zone intersects with the dry line. And I also see a threat of supercells further east as that warm front lifts off to the north through into southern Oklahoma, eventually up into central Oklahoma as well. And could easily see a couple of renegade supercells developing along the warm frontal zone, Lawton up through Chickasha, eventually pushing into central Oklahoma as well. But this complex of storms is really just serving to reinforce the warm frontal zone. I can show you exactly where that warm frontal zone is located so far this morning here as well. We're going to break down some of the latest forecast models. Been moving a little bit slow here these last recent days after that Andover tornado. Had to allow the adrenaline glands to recharge a little bit. I think that they're recharged, ready to go full-blown storm chase mode today. This is the 0 to 3 kilometer energy helicity index, basically a composite index that shows where surface-based instability, the strongest instability, is co-located with 0 to 3 kilometer storm relative helicity. And you can see the brightest colors, pretty obvious, out over southeastern Texas Panhandle through southwestern Oklahoma, nosing into the Oklahoma City area with the warm frontal zone lifting up to about the I-40 corridor through western Oklahoma. You can clearly see the warm frontal zone lifting off to the north. Storms end up firing first along the dry line warm front intersection southeast of Amarillo, north to the southeast Texas Panhandle, possibly down near the Paducah area, out near Turkey, southeastern Texas Panhandle, moving out toward Childress into southwestern Oklahoma. One good thing about this event is that it is going to bring some very much needed rainfall into western Oklahoma. Many of those locations have not seen rainfall in months out here, and so they definitely do depend on severe weather season for rainfall, for soil moisture recharge out here across the southern plains. And it's just been an incredible drought scenario with this year 2 La Nina event. This is a 700 millibar flow, which is basically the low-level jet out across the higher terrain of the Texas Panhandle. You can see 30 to 40 knots over the southeastern Texas Panhandle, nosing almost up to the I-40 corridor by about 20 Z. And this is when storms are going to initiate, right along the leading edge of that accelerating low-level jet, 700 millibar jet, closer to the surface at 850. You can see some nice southeasterly winds backed right up into that area, right off the Cap Rock as well. That elevated plateau across the Texas Panhandle where moisture can pool along the southeastern flank of the Cap Rock. That's where I believe that these storms are going to fire later on today, probably about 2 to 3 p.m. at the absolute latest. And there you can see those storms developing very close to the Clarendon area. Looks like a cluster of storms also develops further east along the advancing warm front, southwest Oklahoma, up to the Oklahoma City area. I've been telling a lot of people just how much this event reminds me of the Cooperton, Oklahoma tornado day. Norman, Oklahoma also had a tornado on that day, April 2012. The Jason's Deli, where I used to eat lunch just about every single day, ended up sustaining damage from that tornado. But the latest forecast models don't seem to advance the warm front further east quite as fast as the previous short-range forecast models there. It looks like the warm front advances a little bit further north and is more sharp across the southeastern Texas Panhandle into southwest Oklahoma. This is by 4 p.m. And you can clearly see the warm front dry line intersection in the eastern Texas Panhandle just southeast of Amarillo. Need to decide whether to blast west on 40 or to take the Highway 62 corridor into the southeast Texas Panhandle. It looks like that warm front, according to the HRRR, lifts just onto the Oklahoma side. The HRRR, though, look at, or the 3 kilometer NAM, however, look at how much further south the warm front is than the other forecast models, and that's why we've got to hit the road here in about 15 minutes. Could easily end up down near the Plainview, Tulia area with that warm front intersection with the dry line. Southeastern Texas Panhandle could easily happen. But because the 3 kilometer NAM shows this warm frontal zone so much further south, I probably will target kind of an average between these two zones, but we definitely need to hit the road quite fast and target the southeast Texas Panhandle. Here's the low-level jet. Look at all these streaks within the low-level jet. That's very interesting. A lot of gravity waves as well. But it does look like the strongest low-level jet nosing into southwest Oklahoma, just on the north side of the warm frontal zone. Also kind of have that 700 millibar flow maximized a little bit further east as well. So the 3 kilometer NAM would suggest that that warm frontal zone might be the play, except that it doesn't really advance it very rapidly off to the north. It keeps the warm frontal zone just south of the Red River. Would actually bring the DFW area into play as well for tornado potential. But once again, this forecast here is going to be quite complicated because we have these dramatic discrepancies amongst the short-range models that are the convective allowing models here. The HRRR has the warm front lifting all the way up to I-40. That would bring Oklahoma City into play for a potential strong tornado threat. Definitely the southeastern Texas Panhandle. You have the 3 kilometer NAM that keeps the warm front further south. Also has the southeast Texas Panhandle in play, but a little bit further south, out down near the Plainview, just northeast of the Lubbock area, with that warm frontal zone extending off to the east to the DFW area, just north of DFW as well. By about 6 to 7 p.m., the warm frontal zone does lift up to about the I-20 corridor, according to the 3 kilometer NAM, which would definitely bring Dallas into that strong tornado threat. It seems, though, that the Storm Prediction Center tends to believe the HRRR. One thing that we can trust these days is that there is going to be a pretty stout elevated mix layer that should be able to carve out the at least the western and southern edge of this convective blob. And so I do think that a supercell that's going to be able to anchor on the southern periphery of this convective blob will have the greatest threat of a strong tornado or two. But look at the HRRR model. What a dramatic difference. It has these monster supercells developing across the eastern Texas Panhandle, pushing into southwestern Oklahoma. These are going to bring much needed rainfall if this forecast scenario does happen. And then they turn into these HP monsters that move into southwestern Oklahoma, building down the dry line into northwest Oklahoma as well. So the HRRR does seem to suppress the convection out east along the warm frontal zone. This is at 4 p.m. Central Time, and it does suppress and that's because it just doesn't lift the warm frontal zone too dramatically, but it still matures those into supercells as they approach the Oklahoma City Metro by about 4 to 5 p.m., and those will definitely have tornado potential, as will these down in North Texas as well. Large hail, tornado threat, but it is still quite a complicated forecast. It does seem, though, that the HRRR overall is trending down a little bit with the leading supercells along the warm frontal zone, and definitely trending up with a cluster of supercells that heads out of the southeastern Texas Panhandle and into southwest Oklahoma. Looking at the surface map, you can see a lot of fog out there along the warm frontal zone. That often happens as you get isentropic lift lifting up and over the stable air at the low levels. Looks like the warm frontal zone is probably down near the I-20 corridor, but the RAP model shows it advancing more rapidly to the west than the east. So I do think that this looks like a pretty impenetrable warm frontal zone to me, with temperatures right near 50, heavy rain, a reinforcing complex of storms that lifted through northeastern Oklahoma. So I do wonder if the 3 kilometer NAM is onto something with being a little bit further south of the warm frontal zone. Maybe down near Childress to Plainview, down in this area of the Texas Panhandle, might be most likely for air mass destabilization. You can already start to see the southerly winds down here. Plenty of moisture with upper 60s dew points. even 70 dew points down into central Texas. Southwest Texas even have upper 60s to near 70 dew points down near the Texas Big Bend as well. Temperatures in the 40s up into southwestern Kansas. Look at that on the cold side of this system. Here is the enhanced risk by the Storm Prediction Center, and that includes a 10% tornado threat, potentially strong tornadoes. Oklahoma City down to Wichita Falls into the southeastern Texas Panhandle, included in that strong tornado zone. Enhanced risk. Also a threat of gorilla hail, of course. Already totaled my rental car. Let's take a look at the RAP model, and then I'm going to look at a morning sounding as well from OUN. There's your warm frontal zone starting to lift north across the western Texas Panhandle, but it is pushed all the way south of the I-20 corridor, according to the RAP analysis here. And we can step this forward to see just how rapidly that warm front advances. This is at 20Z at 2 p.m. Looks like there's a narrow zone even up into Amarillo of surface-based instability. And it looks like I can kind of see two channels where that warm front lifts up. Further east into southern Oklahoma and also up into the Texas Panhandle. You get a nose of instability. Kind of those two areas where the warm front could lift more rapidly northward. You can already see it starting to come north here across East Texas. You can also see that warm front lifting north across the Texas Panhandle. Stepping forward 2 hours with time. Looks like it arrives at the Red River down near Ardmore at about 18Z, 1 p.m., lifting north through the southeastern Texas Panhandle as well. Then by 20Z, it reaches the Red River. That's about 2 p.m. when the warm frontal zone reaches the Childress area. Childress off to the west into the central Texas Panhandle. But notice how that surface-based instability is lifting up into the southeastern portion of Oklahoma, south central Oklahoma as well. Any of the white area that's enclosed by the red ISO lines, that is where you have surface-based instability, and it's moving into the southern portion of Oklahoma. It might be kind of a messy evolution, but I do think the eastern Texas Panhandle, you're going to have an elevated mix layer that will carve out that zone down across that from the southwestern portion of this cloud shield. I think you're going to have more HP supercells along this warm frontal zone that is forecast by the RAP model and by the HRRR to lift up to the Red River by about 2 p.m. Red River, southern Oklahoma, extending off into Childress, west of Childress as well. But look at those backed winds into the Texas Panhandle. Those backed winds in the Texas Panhandle are definitely a force to be reckoned with. Force to be reckoned with out there, and the southern Texas Panhandle, southeast Texas Panhandle looks quite substantial. Looking at the morning sounding here at OU, look at that frontal inversion. So the warm front obviously well south. We just looked at it at the RAP analysis, south of the I-20 corridor. Dramatic frontal inversion. Above that, though, you have the very steep lapse rates. The red line is your temperature. The rate at which it decreases with height is quite rapid into the mid-levels of the atmosphere. This is the frontal inversion right here, saturated. So notice how the green line and the red line are basically right on top of each other all the way up until you get the separation to the north of that, above that up into the mid-levels of the atmosphere. But a very saturated atmosphere in central Oklahoma with that warm frontal zone. And there is a threat of a strong tornado, and that includes Oklahoma City down to Gainesville, west of Wichita Falls, into the southeastern Texas Panhandle. Let's see if what the 13Z HRRR shows for its warm frontal advancement. This is the latest HRRR model. Clearly see the warm frontal zone still pretty far south at about 18Z. 13Z in the morning. Let's go to 21Z. Boom, look at that. Rapid moisture influx all the way up. You do have a little bit less of these dew points that are nosing up into the Childress area, into the southeastern Texas Panhandle. Deeper dew points off to the east along the Red River. That'll include Wichita Falls as well. Nosing into southwest Oklahoma. And this certainly could initiate those supercells further east along the warm frontal zone. At 21Z, you have that monster supercell in the Texas Panhandle. Some isentropic lift into southwestern Oklahoma. These are going to mature into supercells as well. Monster right mover, southeastern Texas Panhandle. You also have a storm to the northwest of Dallas. These are going to mature as they head up toward the Oklahoma City Metro by 5 or 6 p.m. with a strong tornado threat. Look at that supercell lift up to the Oklahoma City Metro, Norman area, Oklahoma City, Purcell, basically the entire Oklahoma City Metro could have a tornado threat that lifts up to that zone about 6 or 7 p.m. Monster supercells then move into southwest Oklahoma, that one from the eastern Texas Panhandle that dives due east into eventually through the Turkey area, southeastern Texas Panhandle, off the Caprock, dominant supercell storm that develops out by about 3 p.m. or so. Look at that, southeast Texas Panhandle develops just south of the Amarillo area by 3 p.m. So it is time for us to hit the road, everybody. Multiple modes of tornadoes. This lead mode as well in the deeper moisture as the warm frontal zone lifts up near the Red River. I do think, though, that the instability is going to lift up to that storm across the Texas Panhandle. Notice how in the latest 13Z, look at the warm frontal zone lifting all the way up to I-40 by 5 p.m. You definitely can see an accelerated low-level jet, a very prime environment over the southeastern Texas Panhandle, feeding into that dominant supercell storm. But any of these supercells that are able to develop in southwestern Oklahoma in that zone of isentropic lift will be lifting up through southwest Oklahoma. Oklahoma City Metro could certainly get a threat of tornadoes. I know there's going to be a lot of people that are playing off to the east to bank for these ones that could potentially impact the Oklahoma City Metro. But you may also want to play that Texas Panhandle storm. Look at that low-level jet surging up into that storm. That's 700 millibars. Out here in the Texas Panhandle, that's a little bit higher up, and you've got about 40 knots nosing up into the southeast Texas Panhandle by about 5 p.m. So I do believe that that's going to be the target, and we are going to have to hit the road here very shortly. So thank you, everybody, for tuning into my weather report so far this morning. Heading off to the southwest, eventually to the west, likely into southwestern Oklahoma, southeast Texas Panhandle, but we'll have to keep a very close eye on the forecast because those lead renegade supercells that could develop along the warm frontal zone, southwest Oklahoma, that could build up into the Oklahoma City Metro. Stay safe, everybody. Stay tuned to those severe weather watches and warnings across the enhanced risk area. A pretty dangerous day for severe